Okay, so these are definite, which means definite integrals. You see numbers right here. So if I gave you this and I told you to integrate, you would get a formula plus C, correct? If I gave you this and I told you to integrate, there would be no C to worry about. Do you see the difference? Do you? This is indefinite. This is definite. So indefinite, we're just getting an equation. So that's why we had all the plus C's, because we're like, hey, there could be a number out there. Here, these are definite. We're going from one number to another. So the C, and we're going to subtract them. So the C values will zero out. So we don't have to mess with C. Does that make sense? Okay. Then here's what we're going to do. All you have to remember is it's the end minus the beginning. So what you're going to do, let's write down what you're going to do. Or think about it. You're going to integrate this like you always did, except you won't add a C on. You're going to plug this top number in and find the answer. And then you're going to subtract what you get when you plug the bottom number in and find the answer. So let's integrate. What do you get when you integrate? There's a 2 and an x. We power up, correct? What's 1 plus 3?
4.
4. And what's, so what can I reduce 2/4 to?
1/2.
Now, instead of writing plus C, right? No more plus C. You draw a bar right there. It's just a line. And you write on it your two numbers. This is proper calculus notation. And now you plug the 5 in here, get an answer. Plug the 2 in here, get an answer, and we subtract them. What is 5 to the 4th? 5 times 5 times 5 times 5. 625 over 2 minus, now plug 2 in there. What's 2 to the 4th?
16.
16 over 2, and we're done. What's 625 minus 16? 609? Easy, right? So the difference between last time and this time, if this were yesterday, you would put a plus C there and go on your way, but it's today. So you're going to draw a bar, you write your numbers down, then you plug your numbers in and subtract them. Easy? Let's try this one. Integrate. What do you get when you integrate e to the 2x? It's 1/2 e to the 2x plus what? What do you get when you integrate 1? Hello? Hello? Okay, so what do you get when you integrate 1? What do you get when you power 1 up? X. And now we're going to draw a nice bar there, and we're going to say 4 and 0. We're going to plug the 4 into this, right? So what do you get? What is 2 times 4? So that's 1/2 e to the 8th plus 4, right? Minus, now we plug 0 in. What's e to the 0? E to the 0 is 1, right? And what's 1/2 times 1? Right, plus 0. So what is this going to be? 1/2 e to the 8th. And what is 4 minus 1/2? 3 1/2, right? Okay. Well, let's look at this guy. I'm going to switch colors so you can tell where one begins and one ends. What do we get when we take the antiderivative of 4x cubed? That's a 4. Now we power up. 3 plus 1 is 4. 4 plus 5x. So what happens with our 4 over 4? It's really x to the 4th plus 5x, correct? We put our bar. We do 5 and 1. So we're going to have plug in 5 minus plug in the 1. What do you get when you plug 5 in here? 625, right? Plus 25. And what do we get when we plug 1 in there? 1 plus 5. Show your steps in your notes. And make sure, since we're subtracting, what do you need to have after every subtraction symbol? What are those called? Parentheses, right? So that you don't forget to subtract. What's one of the major things that we can learn from an antiderivative? Okay, with why we have definite integrals. Let's look at this rectangle. Can y'all find the area of that rectangle for me? Well, how big is it this way? That's 3, right? And this goes from 2 to 6. So that's what? 4. And you know from geometry the area is what? 12 units, right? Well, let's look at this. Given f of x equals 3, what letter variable does f of x stand for? Y, right? We're saying y equals 3, and that was true over here. Could you integrate 3 for me? What do you get when you integrate 3? What do you get when you integrate 3, y'all? 3x. And we're going from where? 2 to 6? Okay, so now I want you to plug those in. What's 6 times 3? 18. Now subtract, plug in the 2. What's 2 times 3? 6. And 18 minus 6 is 12. What do you notice we're doing? One of the things an antiderivative will do for us. What did we do? We found the area under a curve between two numbers. Now, do you think it's important that you use calculus to find the area of a rectangle? Not really, right? You know the area of a rectangle. But what if I gave you shapes you didn't know the area of? Could we now use calculus? Let's look. Let's practice another one. So tell me the area of this rectangle. Let's do one more geometry thing. What's the area of this rectangle? Area is 1/2 base times height. This is geometry. So area equals 1/2 6 times 6, which equals what? 18. Could we use calculus to do this if we felt so inclined? Let's try. Okay, well, the numbers that go right here are your x values. What's your last x? 6. What's your first x? 0. And the equation goes here. What's our equation? Negative x plus 6 dx. So what goes here, y'all, is going to be whatever your y equals is. You have got that? Your y equals will be what you put in there. And then these little guys are your x values. Does everyone see how we're going from 0 to 6, 0 to 6, and there's our equation? Could you integrate that for me? Well, let's see. What do you get when you integrate negative x? Well, we have a negative 1, right? Because there's a 1 in front. This is 1. We're going to go up. And what do you get when you integrate 6? 6x, right? But instead of adding a c, because we know it's from 0 to 6, we're going from 0 to 6. So we're going to plug 6 into this equation, find out what it is. Then we're going to plug 0 in and find out what it is. If you plug 0 in here, what do you get? 0 plus 0, so that's 0. What do we get when we plug 6 in? 6 squared is 36. What's half of 36? 18, and it's negative, right? Now, what's 6 times 6? 36. What's negative 18 plus 36? 18. What do you notice about calculus versus geometry? Same answer. So do you at least believe me when I tell you we're finding the area under a curve? Y'all believe me? Now, I wouldn't use calculus to do a triangle. We just don't need that. But now let's look at stuff. What's the area under this guy? Well, you don't know. You don't have the formula for the area under a parabola. That guy isn't around, so we have to use calculus now. So let's look at this shaded part. We're going from negative 2 to 2. So again, I'm going to go from negative 2 to 2, right? And this is y equals, so that's what goes in here. And we're going to integrate. So what do you get when you integrate 9? 9x. What do you get when you integrate x squared? 1/3 x cubed. Negative 2 to 2. Plug them in. Please use parentheses, or you will probably at some point forget to distribute that minus sign. So I'm just going to plug it in so I can see it. That's 18 minus 2 cubed is 8, 8/3. Negative 2 times 9 is negative 18. Negative 2 cubed is negative 8/3. So that turns into plus 8/3. So what happens when I subtract a negative? Right? I add the opposite, negative. What is negative 8/3 plus negative 8/3? Negative 16/3. It's a little easier if you put your integers together than your fractions. Now we can combine those. So what's the answer to that? To me, it's easier to do this one like this. What is that, 5 1/3? So that'd be what, 30 1/3? 30 2/3. Or you can get common denominators. Either way works for me. Does this make sense? Now you have the choice. When you look at something, you're going to decide calculus or geometry. If you're given an absolute function, absolute value function right here, what's easier, calculus or geometry? Come on, guys. What shape will absolute value always give you? Triangles, right? I could cut it in half and say 0 to here. But anytime you have absolute value, you see a triangle. So on absolute value, you're going to use what? Geometry, calculus? Geometry, right? So area equals 1/2 base times height. My base is 4. My height is 2. So what's my answer? 4. So if I give you an absolute value one, for one thing, you don't know how to integrate that because I didn't show you. But if I give you absolute value, what technique are you going to use? You're going to draw it and see where it is, and you're going to use geometry. It's easier than calculus, right? So we'll practice a couple more, and then you shall be finished. Okay. Oh, now I don't have a picture at all. What should I do if they didn't give me any kind of picture? I should sketch it. So what is the equation x look like? Well, it's a 45-degree line, right? And I'm going from where? -2 to 3. So I want to use calculus on this. So we're going from -2 to 3, and we have x dx, right? What do you get when you integrate x? That's 1x. X up is 2, 2. Okay. Plug that in for me. Come on. 3 squared is 9. 9 halves minus 2 squared is 4. I'm going to leave it 4 halves and not say 2, so I could say 5 halves units squared. Now I want you to use geometry and use your geometry, because I want you to see a special relationship of something that just happened. So what's the area of this little rectangle? What is the area? Come on, y'all, it's 2 by 2. What's the area? This one is what? 3 by 3, so what's the area? What do you notice? What do you notice about these numbers and these numbers? They match up, right? Now, the area of this is 2 and the area of this is 9 halves. So this would be like 4 halves. So if the area of this is 4 halves and the area of this is 9 halves, how come it's not 13 halves? What conclusion could you come to? What do we have to do with area that's below the curve? Subtract area below the curve. So I like this problem. So you see that relationship? Right? I want you to make that, notice that the calculus answer is correct. So this lets you know when I'm above the x-axis and I'm below the x-axis, right? All right. You notice that relationship. Now we're going to go to this one. How do we integrate this guy? First, let's draw this. Which direction do we go, right or left? We go left 2 because it's added. Square root function looks like that. And we're going from -1 to 7. So that's, so we want the area under this curve, correct? So that's really x plus 2 to the 1/2. There's a 1 out front. What do you get when you power up 1/2? Right? One half plus 1 is 3 halves. So that's really 2/3. X plus 2 to the 3 halves, right? And we're going from -1 to 7. So we're going to plug 7 in, plug -1 in, and we're going to subtract them. No big deal. What's 7 plus 2? 9. The square root of 9 is 3. 3 cubed is 27. If we plug -1 in, -1 plus 2 is 1. 1 squared is 1. Cube root of 1 is 1. 1 times 2/3 is 2/3. So what do we get here? What's 20? I could make this just 9 times 2 and get 18, right? And what is that? 17 1/3 units squared. Right? Now I could also just multiply that and subtract, and whichever way. Okay, let's try this one. Before we do it, are you ready? I want you to make a guess. What does x cubed look like? And we're going from -2 to 2. So we want this and this. Before you do any work, can anyone tell me the answer? Come on now. Think back to the first one we did. What's the answer going to be to this one? What do you think? Well, let's do it. Let's integrate x cubed. What do you get when you integrate x cubed? 1/4 x to the 4th from -2 to 2. What's 2 to the 4th? 2 to the 4th is 16. 1/4 of 16 is what? 4. -2 to the 4th is 16, and 1/4 of 16 is 4. And what's 4 minus 4? 0. But we kind of knew that going in, didn't we? Why? Well, this is going from -2 to 2. This is above and this is below, and it's exactly symmetrical. So I got a 0, just like right here when I added this and subtracted that, right? So are you noticing we're adding above and subtracting below? You got it. That's it. That's all there is to definite integrals. So we are ready to start some homework.